Hi everyone. So today we are going to build Agentic system with two frameworks. First with ReAct Agentic framework and second a little enhanced using node pool architecture. So I'm not going to waste any more time and directly jump on to building this system, Agentic system from scratch. So let's first understand what ReAct Agentic framework is. So I did a quick Google search, and if you do too, you'll see a lot of images, and this is how it looks like. ReAct framework or ReAct pattern looks like this. So what happens when you in an agentic system, when you use an LLM to get the answer to some question, it uses its reasoning, right? So it thinks about it. And then you also know in building agentic system we have a way to provide tools, accessibility to our LLM so that they can use some special functions, we call it tools, to get the correct answer to its question. Okay, so in the ReAct pattern what happens, whenever someone makes a question to the agentic system, it thinks about it, and if it sees, okay, do I have any tool that help me answer to this query? If yes, it performs the action, and then it again think and it makes an observation. Okay, I received the output. Do I have all the answer, or do I need to do something else? So it will go back to, if it needs to get more answer, or if it is not satisfied with the answer that the tool has provided, or it needs to get more information, it will go back to the start and think about it, and then figure out which tool will help in answering the right question, the complete question. Okay, otherwise it will end and will go to and it will end the flow, and then will go to the user with the answer. You might not be able to understand what I'm talking about, but hold on, whatever I have said till now will make sense when we will be building the system from scratch. Okay, so this is what we are going to build here. Okay, let's look at the data a little, and then I'll explain you what we are going to build. Okay, so this is one file of, let's say, 155 lines, and this is going to be ReAct pattern framework agentic system that we are going to build. Okay, so let's look at what we are going to build. We'll be having a couple of tools with us. Tools is nothing but special functions that has access to some data and provides answer. Okay, so we are going to have some mock data. Let's just follow along. Okay, I know that it will not make sense initially, but just stick to the video, it will start making sense. So we have some employee data, okay, where a dictionary with employee ID, let's say E001, has information like name, Alice, role software engineer, and similarly to E002, E003. Then we have another dictionary called a list of mentors, where the key is the skill Python, data science, SQL, and then what are the IDs of the mentors that have that particular skill. So these are the mentors that have Python skill. Then we have another dictionary which talks about whether that particular mentor is available or not. Then we have another dictionary that talks about that this data gives us the deep more information about a particular mentor. For example, this M001, the ID with this mentor, has name Dr. Smith and has expertise in Python and SQL. Okay, so we have built some tools which is not doing nothing but, let's look at this tool called get employee information, which is doing nothing but whenever you provide any employee ID to this function, for example, if we provide E001, it will just give us the information about that employee. So this is doing nothing but giving us the employee information by specific employee ID. This is one tool that we are going to use. Another tool that we are going to use is find mentors based on the specific skill. A find mentors, which will take the skill as string and provide the mentors that have those lists, the list of mentors that have that particular skill. For example, if we provide Python, it will just give us this as the output. Okay. Then we have another tool called check availability, which is going to check the availability, as in check whether that particular mentor with mentor ID is available or not. So it will do what? It will simply go to this mock data availability and see if particular M001 is available or not. So it will just return this boolean value, true or false. Then we have another tool called get mentor profile, where now we have received everything. If we want to know more about a mentor, we'll pass in the mentor ID and we'll get more information about that particular mentor. So this mock data, this data will be used for that. So we'll just pass in, okay, this function that get mentor profile for mentor M001. So it will return this list, dictionary actually. Yeah. So yeah, we have 4 tools. Let's go look at our flow diagram. So this is what I have talked about. We have 4 tools, helpful functions, and we call helpful functions in the Agentic world tools. Okay. So we'll do nothing but we'll bind our LLM with those tools. Bind as in we'll make our LLM aware that we have a list of tools available to you that you can use if you want to. Okay. So this is what we are doing with this bind tool function. Before that, let me show you. I've just done nothing. I've used this. I'm using Gemini API to make the request. So here I've passed the model name, the temperature. I've kept the temperature as 0.0 because I want my system to not guess anything or not be creative. I want my agentic system to be predictive. Okay. So I have kept the temperature as 0.0 to not be creative. Okay. Now maximum retries is only to save my costs because I'm using free API. Okay. So we have understood all what we have seen till the line number 110. Now imagine we are just left with a line, let's say 40 lines. So the real meaty thing in what I'm going to talk about the ReAct framework is nothing but a line, not even 40, actually 20 lines only. This is just a prompt. Okay, so the 20 lines only. So let's understand a little system prompt. So what we have, let's go back before understanding the system prompt. Let's understand how our graph looks like. So I'm using land graph for building this whole agentic system, or a graph where I have 2 nodes. First I have assistant node and second I have a tools node. Okay, so I have 2 nodes, assistant node and a tools node. Okay, so now assistant node has access to, has a callback called assistant function, which we'll understand later. Then the tools node will call this tool node, which I am importing from the langgraph.prebuild functions, which is nothing but a dumb executor which is simply going to execute the specific tool function. Okay, nothing. So let's understand. Whenever someone is going to come, we have added 3 edges here. Whenever someone is going to come, they are going to start. Okay, so they are going to come here and then they are going to go to the assistant. They will go to the assistant. When they will go to the assistant, which function is going to run? This function is going to run. Okay, and once assistant will reply something, will give a message, it will go to come out of it, and then we have conditional edge called assistant with a callback called tools condition. So again it is a langgraph pre-build function. It does nothing but it checks whether the response from the AI, from the LLM model, contains a key called tools calls. I'll show you later. If it does, it will execute the tools node. If not, it will simply end the call. this is what I'm talking about. At start assistant, if in the AI message the response, it will check whether it has a tools call. If it has the tools call, it will execute the specific tool function and go back to tool function, otherwise end. Okay, now once it does that, we have also added one more edge called tools. Once it executes the tool, it will do what? It will go back to the assistant with this response. Okay, so again, start assistant. If there is any tool call in the response from this assistant, it will make call to that function from tools node, the tool function, and go back to assistant. Again, assistant will make a query, make a call to the LLM with the information, and it will say, okay, does it again need any tool call? If it does, keep on doing this loop, keep on going in this loop, and will end what? When there is no tool call, when the LLM will say, okay, I have received all the information that I could have from all the tools that I have access to, I don't need to do any more processing, I'll end the execution. So this is what we have built. Okay, let's look at, before we execute this, let's look at the system prompt for our assistant. Here the main, the hero of this whole architecture is nothing but assistant. Okay, so assistant is doing all the heavy lifting. It is deciding whether to make a call, tool call or not. Okay, so let's read the prompt. Here it says you are a mentoring program assistant. When asked to find a mentor, you'll have to do what? First, get the employee's information, then find mentors based on the requested skills. Check the availability of the mentors one by one until you find an available mentor. If you find an available mentor, return their profile. Find the mentors based on the requested skills, and then check the availability of the mentors only one by one until you find an available mentor. And once you do that, if you find an available mentor, return the profile. So you see, in the prompt I have provided step-by-step guide for the assistant on how to execute, how to return the answer to the user's question. And I've also explicitly mentioned that, okay, always use the tools to look up the real data. Do not guess. So it is helping me not to hallucinate, not helping LLM not to hallucinate. Okay. So let's look at the question that we have put up. The question is simple, that find an available mentor for employee E001 who can help with Python. Okay. So we are using MLflow to track how the execution goes. I'll show you, and with that we are invoking our graph, whatever graph we have built with 2 nodes, with this message, and this is a human message. Okay, and once we do that, so I've explained everything. Let's go and run this. So I'll simply go here, I'll say uv run python, which file? ReAct prototype. Is it ReAct prototype? Yes. Yeah, so it is using my API, which I will not show. But yeah, let's wait. Why wait? Let's come. So this is I've already run the MLflow here. I'll refresh it and I'll see that I have one tracing ID which is in progress. Hopefully it will be done soon. Let's say it is done. So hopefully it is done. Yes, it is of March. Okay, May 04. So which is today. So I'll come here and see what is happening. Here our question was what? our question was that find an available mentor for employee E001 who can help with Python. Okay, and this was the question. What we have received as the answer, it says that I have found an available mentor for you with Dr. Johnson, who is available and has expertise in Python and data science. Let's check if it is correct. Dr. John has an expertise in Python. And did we want expertise in Python? Yes, we wanted expertise in the Python. Perfect. So our agentic system is working without any hallucination using the real data. Okay. So let's look at the flow up once again. So we are, I'll show, go back here, I'll show our user has queried this. So it will make a call to this, the system. Okay, the system with this prompt. We just understood. And what have we received as the output? We have received as the output with this. This is what we have received from LLM. This is the JSON that we have received from LLM. And here you see that it has a key element called tools call. And this is what that tools condition function is using. If the AI message, this AI message has this tools call, it will do what? If the AI message has a mention or an element called tools call, it will go and execute the tool function, otherwise end the call. So here we can see it has a tool call and it mentions which tool call. So this is how when we bound our LLM with all those tools, if you remember, LLM now knows there is a function, there is a tool called get employer info. So it is going to use that. It has provided that function name and the argument E001. Okay, so then it will go to tool condition and it will execute which node? It will execute tools node. It will execute which node? It will execute tools node, which is going to make call to this tool node function, which is nothing but a dumb executor who is going to make a call to this function and return the employee information, which is nothing but Alice and with role software engineer. Okay, so it is going to make a call to these tools. We see, if it has returned this, it has returned this only. Now again, tool will go back to assistant. Again, how? Where? Because we have mentioned it here. Tools will go back to assistant. So it has gone back to assistant with all the information. You see, all this information is being added. Whatever this happening, all this call to LLM tools is being added to the message, the state shared by all the nodes in the graph. Which state? Message state. Okay. So yeah. Now then again, let's say it has gone back to assistant. And what has assistant? So this is the input, and what is the output? Output again will contain tool call. Now it contains a tool call to which tool? Find mentors with this skills, with this argument. So it will go back to I'll remove this. It will go back to find mentors, which will return the information about for find mentors. What do we have to find? The mentors with what skills? Python. So it should show us what? This is the list that it should show us. Okay, so it has gone to this tool. It will go to this tool and it will return. This is the list of mentors which have that skill. Then again it will go to assistant. Assistant again has all this information, will make a call to LLM, and LLM with all this information, whatever has happened so far, and then will output tools call. Now it suggests that do a tool call with this tool and with this argument. Okay, so it will go to this tool, it will go tool query with this argument. It checks whether this mentor is available or not. So it will go M001. Let's see if it is available. No, it is not available. So it will again go back to the assistant with all this information. Then assistant says, okay, now check the availability of M002. How does it know to check the availability of the next? One by one, because we have explicitly mentioned it here that check the availability of mentors one by one until you find an available mentor. So this is why prompts, a descriptive, well defined plan, step by step prompts are really helpful here. So it will go back to this tool with mentor ID M002 and make a call to check availability tool, and it returns true. Let's come back. It returns true. M002 is true, and once it returned true, okay, now assistant will pass on all this information that see this M002 is available. Then the output that we have received from LLM is now that go make a call to get mentor profile to get the profile of this mentor. Again, how does LLM know to make a call to this tool? Because we have told it. We have said that check, if you find an available mentor, return the profile. And what tool do we have to return the profile? This. LLM will use this information. Okay, I have to return a profile of a mentor. There is a tool that says that get profile of a mentor, so I can use it. So it will use this get profile, not, let's say, tool condition, not assistant, and say what it will return. It say get mentor profile with this ID. So execute the tool again, and it will return nothing but the profile of Dr. Johnson with the expertise. And the assistant has now all this information. Okay, now assistant has all the information and it will execute nothing. See, in the tools call, it is a blank array, empty array. So if it is blank, which means LLM's task, it has nothing more to do, it has nothing more tools to use, it has all the answers that it needs to answer back to the user. So it has populated this content section. Once we have that, the tools condition will stop, no final answer, and the graph. And now assistant has the answer that, hey, I found an available mentor for you, Dr. Johnson, who is available and has expertise in Python and data science. So our ReAct framework, our agentic system implemented using ReAct framework, works flawlessly. Okay, now can we enhance it? There is this framework that is heavily being used in the agentic AI world, but there is one more framework that I came across recently, and I was studying it, and then I felt like, okay, let's make a video out of it because this is interesting. So there is an enhanced framework or architecture that we can use along with this ReAct framework. With this architecture is called a node pool architecture. So what I'll do, I'll go back to my flow diagram and show it to you. Okay, so this is how it looks. So now instead of having one agentic system, one system going through the loops, we'll do what? We'll have different pools of node, and so yeah, let's say here our agent LLM was aware about all the tools, right? And now what if agent will make mistake? Okay, now here we have availability of 4 tools only, and let's say if we grow to like 100 tools, now LLM has access to 100 tools. More options will give to LLM, more chances that it is going to hallucinate. Have you heard about that principle of least privilege? The least privilege a thing, an object or a LLM has, it is going to produce a correct output. So this node pool architecture is built on this principle only, the principle of least privilege. So we'll do what? We'll split these tools into their own pool where they make sense. For example, get employee can go to its own pool, find mentors can go to its own pool, check availability and get mentors profile can go to their own pool, but they will go to together because they matter about getting the information about the available mentor. So there is a pool, or let's say there is a system, a pool where all the tools that matter about that particular particular query will go together. So we have one pool for this, one pool for this, one pool for this. Okay. And what will happen whenever we are going to make a call, whenever we are going to make a call with the same question, now we'll do what? We'll have three elements. We'll have a router, we'll have a dispatcher, and then the different nodes, pool of nodes. Okay. So again, I'll repeat. We have a router, we have a dispatcher, and then we have pools. Okay. So what happens? Let's follow along with the video. You'll understand later. So router will do what? Router will so again, this is again, you have seen that I have used land graph, so I'll be using land graph again. So we have a graph with nodes. Okay. So we have three nodes, this router, dispatcher, and a couple of nodes which are nothing but pool of nodes. Okay. So forget about pool of nodes. Let's first understand what a router and dispatcher is, and then we'll come to the later part, and then you'll understand what I'm going to talk about. So we have a router whose job is to just give us a plan that we are going to use. Okay. A router's job is nothing but to give us the plan to return, a plan to execute such that this will return the right answer to user. Again, I'll repeat, a router's job is to give the correct plan, nothing. Okay. So let's come, and a dispatcher's job, let's first understand dispatcher, and then we'll look at the code, and then we'll understand line by line. And the dispatcher's job is nothing but to execute that plan one by one. First, let's say router has returned a plan, let's say plan A, plan B, plan C. So router will execute plan A. Once it will execute plan A, and there is nothing needs to done in plan A, it will move to plan B, then it will move to plan C, and then we'll end the execution. Okay. Now and then how those plan A, B, C will be executed, that is how the pool of nodes will come into the picture, but we'll understand that later. Now you have understood we have three elements here, three layers: router, dispatcher, and the pool. Router, dispatcher, and the pool. What we have done, we have segregated everything into their own section, and when we do that, it becomes easier to maintain or scale. So this is the whole point that we are discussing about this node pool architecture. Okay, so let's look at the code. We are doing something similar. All the libraries are the same that we have imported okay, this is ReAct. Let's load the other file. So all the libraries are same that we have imported in the ReAct prototype. You can find the code for this in the GitHub repository that I'll be pushing. We'll load the environment that you can also load to pass your API keys. Then we'll add the MLflow LangChain autolog to trace what we are doing, to show what I have shown you through MLflow. Doing the same thing, we are using the same mock data, so I'm not going to explain the same thing again. The tools are also the same as it is, ditto. Okay. Then what we are doing, we have created three pools, I told you, right? We have created what? Three pools. We have a pool, one called employee lookup tools, that has access to this tool. We have another tool called mentor search tools that has access to find mentors. We have another tool called availability check tools that has access to two tools, check availability and get mentors. Okay. Again, what? Principle of least privilege. It will help us, our LLM, make less wrong assumptions or less assumptions and be more concise. Alright. Okay. So now what we'll do, we'll bind our LLM with all these tools one by one and create a tool node. Same thing that we have done last time. Okay. So what are we going to do next? If you remember, in the ReAct prototype, we have used a pre-built already provided message state by LangGraph, but here we are going to create our own state. Why? Because we want to, a state is nothing, you know that state is nothing but a state, a data that is shared amongst all the nodes in the graph. So we are going to create a custom state in this node pool prototype architecture, where we are going to track the messages that are being exchanged between the LLM and the user, LLM tools news user, LLM tools user. Then we'll also store the node plan. We'll store the current node index, the index of the current plan executing. So we'll get a list of plans, and this element will be used to track which is the currently executing node, okay, from the plan. Now we also keep a track of active node. We will be using it for our tools when they'll run. You will not understand right now, but you will understand in a couple of minutes. Now let's refine our nodes. So before this, let's first understand, build the graph. Okay, this is same. We are building a graph, a state graph. With what state? We are using a state called agent state, where we are tracking 4 elements: messages, current node index, active node, and the node plan. Okay, so we have some nodes. We have a router node which makes a call to this function. A dispatcher node has a function called by function this. A tools node has tool node, which is nothing but whenever a tools node will be called, it will access this tool node. Tool node is nothing but a tool node that has information about all the lookup functions, all the tools and their callback function. Okay, so whenever this tools node will be called, it will come here, and then it will execute the respective callback function for the tool. Nothing. Okay. Then we have employee lookup, we have a mentor search, we have an availability check, and then we have a format response. Let's not bother about these 4. Okay, but let's say we have some nodes, these 4 nodes that make a call to their respective function. Okay, now we are connecting all these nodes together with this add edge function. So how are we starting? We first make a call to our router node. Then router will make a call to dispatcher, and then dispatcher will make a call to all the respective nodes. Let's not get confused and follow this here. Let's come here and understand what router does. So whenever someone starts with what question, let's say same question comes here: find a available mentor for employee E001 who can help with Python. Okay, so this question is coming. User is asking that help me find a mentor and my employee ID is E001 and the skill that I have is Python. Can you help me find a mentor? Is the question. Okay, so it will go to our graph. It will go to our graph. Graph will start and make a call to the router node. The router node will come here and they'll go back to our router function. Let's go yes. Okay, so let's understand router. This is like, once you understand router and dispatcher, you have understood everything about this node pool architecture, trust me. So we have created a dictionary of all the valid nodes. Okay, and then we are saying, okay, this is the system prompt for a router, and we are saying, hey, you decide whenever we make a call to this router, this is the prompt that is going to run. So the LLM will get this, that hey, you decide which workflow node to execute in the order specified. Available nodes that it has a node called employee lookup, it has a node called mentor search, and then it has a node called availability check. Employee lookup node is used when you have to look up for an employee's basic information. Use this node when you have to search for the mentors by skill. Use this node when you have to check mentor availability and get their profile. So what are we doing? We have created 3 nodes. we have created 3 nodes, and we are saying, okay, router, use these nodes in the specific order only when you have to do a completed task. And then we are saying return only a JSON array of the node names in the execution order. So it will return this, this and this. Nothing. So router will do what? It will return this, this and this. Okay. So example also we have provided. Yeah. Techniques of writing a good prompt is by giving good examples, right? So router will come with agent state. Agent state has nothing but that question. Here we are appending the system message, the system prompt that we have created, where we are explicitly saying that follow this order only, and then the user question and invoking the LLM with this message, and then we receive a response. Okay, let's go and show you. Come here, I'll show you that I ran this node pool framework before, and let's trace how it works. So whenever we make a call to our LLM, this is what we have called. You decide blah 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 blah, and we receive something. This is what we have received. This response is what I'm showing you. This response is what I'm showing you. Okay, so we'll get that, hey, this is the text and this is the output, the plan. So we have received a plan, which is first execute node employee lookup, then execute node mentor search, then execute availability check. Yeah, okay, and then we are doing some sort of programming to return that. Okay, checking that whatever it has returned matches the valid nodes. That's why we have created this array. Okay, so we are returning nothing but this order, a plan on how to execute each node in which order. Okay, so first execute employee lookup, then mentor search, and then availability check. So router's job is done. Router job is to just create a plan. Now remember, if you are implementing or building this for a production level application, you can also use a less expensive model here, because here the task is almost predictable. No creativity, no complex model you have to use. You can use a separate model to make a plan. Okay, so once you do that, but I've used the same model, but you can use a separate model. That's what I'm saying. Okay, cheaper and faster model you can use to make this plan for the router. So the router has returned us a plan that executes employee lookup, first mentor search, and then availability check. Let's come to our architecture. So the router has a plan. Okay, if you remember, here we are returning the plan in the node plan, the agentic agent, this few agent state, we are returning node plan as the plan, and then we are starting the current node index as 0. Just remember this. Now once it gives that information, as to the dispatcher. Okay, it gives that information to our next node in the graph, which is dispatcher. So it will go to dispatcher, where the dispatcher will run this function. Dispatcher will run this function, which is nothing but it is just passing. It is doing nothing. Okay, why? Because the main logic is in the conditional edge. So let's come, we did not explore last time. So here the dispatcher will come out of this add conditional edge will do what? Whenever the graph comes out of this particular node, it will execute this after dispatcher function, and this after dispatcher function will do what? Just a second. Yeah, will do what? It will do nothing. Very, very simple function. It will do nothing. It will do what? It will get the current index and get the node plan. What was the node plan? Let's come back. Node plan was this, execute this, and the current index was nothing but 0. So it will take the current index, which is 0, node plan is that. It will say, okay, have we executed all the nodes? Have we reached the final? The current index is greater than or equal to the length of plan? No, it is 0 only, right? So it will not fall in this. So it will come to this return statement, and it will return the what? It will return nothing but employee lookup. So it will return nothing but employee lookup. So let's go back. If you remember, conditional edge we have added. So we are saying, hey, whenever a dispatcher node is called, execute this function. Once this function is executed, it will return the current the string, the name of the plan at current index, which is employee lookup for now. Okay. So whenever that is returned, what node we have to execute? We have to execute employee lookup node. What node we have to execute? We have to execute employee lookup node. So we will execute this node. So now remember I told you, let's skip that section for now. So yeah, so whenever this node will be executed, it will make a call to this function, and this function is doing nothing. Very simple thing. What we were doing earlier, how here we have divided into separate pools for extensibility and scalability and for clean architecture. So here we have a separate node for doing all the things regarding to employee. So this function will be called for that lookup node, where the prompt is this, that hey, sorry, okay, one more thing. Here we are binding our LLM with this lookup tool only, with this node pool only. Why? Which is our node pool? This node pool has access to this tool only. Okay. So here we are explicitly binding our LLM to this tool only. Why? Again, the principle of least privilege. Our node is not aware about any other pool, so this LLM has access to these tools only. So we will not use any other tool which is not required. Okay, which means it will be more accurate because of least privilege principle. Okay. Okay, so we are binding this tool only, the tools accessible to this pool only, and the prompt is you look at a single employee ID, extract the employee ID from the user's message, call this function once with the ID. After you see the tool result, immediately return a text summary. Do not call any tool again after receiving the result. So we are telling the exact plan to our LLM. Okay, then we are using that, hey, we are saying that use this function, okay, use this tool, and once only. So we go back to this, we use this employee lookup LLM which is bound to this tool only. We bind all this, concatenate this prompt, system prompt with the user message, not the user message, all the information that has happened, the node plan, the dispatcher output and everything, and then we get a response. Again, if you remember in the ReAct flow, what we did, we were using a thing called tool call to see if we have to continue in the loop or exit the loop. We are doing the same thing here. We are saying, hey, if the response has a tool call, return the response and the active node as the current node. We are saying what? We are saying, hey, if you have a tool call in the response, just return the message and do what? And return the active node. Okay. This is because what we are doing here, you will understand why we have added that active node. It was something that it took me some time to understand why we are using this active node element. Okay, so whenever the graph enters a pool, we are making a note of the active node, which is nothing but that lookup, that particular node. So then it will go to this, after dispatcher, this lookup node, if you remember, this lookup node will come out of it. Then we have one more conditional edge here. Okay, here it says whenever these conditional edges are called, they are executed. After they are executed, run this after specialist function call. So it will go to this function, the tool, not the tool, that the node has executed, the node has done nothing but invoked the LLM with saying, hey, you have to use this function or tool, and this is all the information that you have, and once it does, it will make a call to this specialist call function. and it does nothing. It takes the last message and it says whether again it has tool calls, return the tools, otherwise dispatcher. Now if it has the tool calls, it will return the tools, otherwise it will return the dispatcher. Let's understand what we have discussed. Okay, so router has given a node plan. It goes to dispatcher. We saw that in the dispatcher it runs after dispatcher, which does nothing, which does nothing but returns the name of the currently active node, which was at current index. So the current node index was 0, so it returns this one, the employee lookup. Then from dispatcher we saw, okay, if it returns employee lookup, run this node. If it runs employee lookup, if it runs it returns employee lookup, execute this node. It goes to execute employee lookup, it goes and runs that function. Once it runs that function, it makes a call to the LLM with that prompt that we have given. Hey, this is you look blah 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 id once, and return. This LLM has returned what? It has returned a tool call, because we have explicitly said that use this function, and we have also bound our employee lookup LLM to that tool of our pool. So here we say, okay, hey, use this get employee information with these arguments. Now we have a call to tools. Okay, once we go to this after specialist tool for all this specialists. These are the specialists. If here we have received a tool call and we go to this function, we have received a tool call, we'll simply receive that, hey, we have received a tool call, so return tool. Now once we return tool, I've told you in the conditional edge what happens, what is returned. It executes the value of it. So it executes tool node. It goes to this tool nodes and it does nothing. What it just execute, it is just a dumb executor. It goes to the specific tool and executes it. So which tool we have to execute? Tool. It will go to tool node. It will execute what tool? Fit tool, not this. It has to execute get employee info tool. So it will go and execute this, and it returns nothing but this. So we'll come, it makes a call to get employee information, and it returns nothing but success. It returns nothing but okay, let's see what happens. It returns nothing but it returns this output. Okay, correct output, the same we saw in the ReAct framework. Okay, now if you see in the edge in the graph, we say that after the tool call we are also adding one more edge conditional edge, where we say after you have executed the tools call, run this function. So we'll go and see what is there in this function, small function. So it does nothing but it returns the value of the active node from the state, agent state. So remember, when that specific specialist node was called, it had set the active node as its own name, the node name. Okay, now whenever the graph goes to tool is not aware which was the active node running. So that is why we have to use this active node element to keep a track of which was the active node running. So now this tool will do what? It will just return the active node. So what was the active node? The active node was just a second, not here. Active node was this only. Okay, active node was this only. Here active node was here, it will come here. Here the active node was this employee lookup only. Okay, so it will come back to which, from conditional edge we will see, it will come to employee lookup. It will run this employee lookup node again. It will run this employee lookup node again. Why is it running that employee lookup node again? It took me some good amount of time to understand this logic. So it made a call again to employee lookup node. Here we say it make again a call to employee lookup again. Why? Because tool has provided the information that the employee LLM wanted to know. Okay, they are all working in their own silos now. So the employee lookup LLM has got the information. Now employee lookup may want more answers, right? Or can have access to more tools, right, in that pool. So LLM, the employee lookup LLM has to decide whether it has executed what it wanted to execute, to get the right answer, the complete answer. If not, make a call to tool again. That is why we need the active node. Why? Because the employee lookup, the specialist node, to enter the pool will go to its tool call, and once that tool call returns, it will go to the specialist node, which is employee lookup here. Once it goes to that employee lookup here, it will say, okay, hey, now I have all the answer. Now employee lookup tool wanted what? Employee lookup tool wanted what? It just wanted the information about the employee. So it has nothing to do more. So it just wants employee information. So its task is done, right? So here the LLM say, oh, now I have all the information. This is the input, and here I'll show you. Here the output is nothing. This is what has gone to the employee lookup LLM, and here it has written, hey, I have received all the output. That's why the tool call is nothing. I don't need to call any other tool in my pool to get the information about the employee. I have all what I needed. So I'll simply return the content which says, hey, which has summarized that the employee with ID 001 is Alice, who is a software engineer. Perfect. So its task, this pool's task is done. Now it will go to what, if you remember, it will go to what? Dispatcher. I'll show you. It will go to what? Whenever a specialist node runs, it will go to after specialist call. After specialist call, will check again whether it has a tool call. It says, no, I don't have a tool call. Why? Because we just saw we have a content. So it does not have a tool call, it will go to dispatcher. And dispatcher will do what? Because the execution for this specific tool is done, so it needs to the next tool, right? It needs to the next node. So the dispatcher will be called, which again will make a call to this dispatcher function, which is doing nothing but passing, because the main logic is being handled by the conditional edge, which will go to this after dispatcher function, which will say, okay, the current, if you remember here, one more thing, the current node plan. What was the node plan? The node plan was this. So this is executed. So it will move to mentor search. How? If you see, when we were coming to this employee lookup, we are increasing the current node counter also, because we have executed this part. We have to now move to the next part. Okay. So the current node counter is, once this part is complete, it will go back to dispatcher, and the dispatcher will come here and say, okay, the current node index is 1. Node plan, from node plan, what is the keyword? What is the name of the node at index 1? It is mentor search. So it will go and return mentor search here. So now dispatcher, this after dispatcher will return mentor search, which means which node will run? Mentor search node run, which will execute this function, and it will do the same thing. Again, it has its own LLM tools, again its own prompt, which says nothing but says, hey, you have to make a call to find mentors once, and same thing. Then again make a call, and then check whether it has a tool call. If it has a tool call, then set the active node as the current, because tool needs to know which node to return back. Otherwise, increase the current state to 1 and return the response. Same thing what happened with employee, same thing will happen here. So again, so we were here, dispatcher has returned current node index. So after dispatcher has returned mentor search, which will go to mentor search, which will say, hey, make a call to LLM will reply, hey, you can do what? You can do what? You have to make a call to this tool calls find mentors function with this keyword. So again, this once that is done, once all the specialized nodes execution is done, it will go to after specialist call. This will go to after specialist call, which will say okay whether it has a tool call. If it has, returns the tool because a tool needs to execute, otherwise go back to dispatcher. But here we have a mention of the tool call, so we'll go and run this tool. Which tool? Find mentor. It will run, it will return what? It will return this, the list of mentors who has Python skill. Now again, once the tool call is done, it will come to our conditional ledge, which will make a call to after tools, which is doing nothing but returning the active node. So what was set as the active node? Find mentors. So it will return to mentor search. Okay, so not find mentors, mentor search. Mentor search again will say, hey, now I've received all the input. This is I've received the this is what I've received. I've received the mentor profile also. These are the list of mentors. What more do I need to do? It says, hey, you don't have to do anything. You have received all the answer that you needed for this pool, for this with this LLM. Okay, so again, now we don't have after this, after this tool we don't have what have we executed? So we have executed the conditionalized the specific mentor search specialized nodes. It will go to this after specialist call, which will come here, which will run this and say, does it has tool call? No, it does not. So it will return to dispatcher with an incremented current index, because here it will say come here, no tool call, increase the current index, then will come here, return the dispatcher. Now again we'll go back to dispatcher, and dispatcher will do what? Dispatcher will go to the next node in the plan. So here it will go to availability check. Now availability check will come again. After dispatcher call will be made with this information. Here the assistant will be given this information, and once here dispatcher has returned what? Dispatcher has returned availability check, which means this after dispatcher function will be executed, which will return availability check, which will execute availability check node. Now availability check node is nothing but similar to what we have done so far. Has its own prompt, bind its own tool. Now it binds two tools. It binds what? It binds two tools. It binds, just a second, binds check availability and get mentors profile. So the pool is bigger. Okay, so it binds two tools. So same thing, it says, hey, you check mentor availability one at a time. So you have to check one at a time. Take the list of the mentor IDs from the conversation, call check availability one by one. I am emphasizing on one by one, and as soon as you find one that returns true, call the another tool, call get mentor profile with that mentor ID, and then stop. You don't have to do anything else, and then do not check any more mentors after finding an available node, and return the available mentors profile. So this is what the tool, so the pool of availability check has to do. So it goes here with that information. So it goes here. It goes with all this information, that this is the information. I am going to check for the availability of these mentors, and it says, hey, I am going to check for, this is what you have to do. It says, hey, I will help you check for the mentors who can help with. So this is what it has written, and there is a tool call also. So it says, hey, use this tool to get the availability check for the mentor of this ID M001. If you remember, in the prompt we have explicitly said that check one by one and then stop once you get the answer. So it is checking from the list of available mentors. We have a list of, let's say, this. It is going to check for this, this and this, okay, until it gets an available mentor. So it checks that. It has a call to tools. So it run after specialist function. So it will go, it will come here, availability check after specialist. Here it says, hey, does it has a tool call? It has. So make a call to which node? Tools node. So it will go to tool, run that, it will go to tool, run that specific tool, which will return output. What is that? False. That M001 is not available. You remember, it was not available. M001 wasn't available. M002 was available. Now it will go back to after tool call. Remember, after tool we are using to go back to the node that has made a call to tool. Okay. So after tool call, go back to after tool call, which will return the active node. Active node here is what? The active node is check availability. So it will go to availability check node, and then it has all the information. Again make a call to LLM, say, hey, this is all the information so far now, that M001 was not available. What do I need to do? It says, hey, now check, use the tool called check availability with this mentor ID. Again we'll go back to after specialist, okay, and set the active after specialist and say, hey, it has a tool call. Yes, because it says check the availability for M002. So it returns the tool, which will return this. Go back to tool node, which will execute the specific tool and will return true. M002 is available. Now again go back to the active node, which was availability check. Now availability check again will make a call to LLM with all this information, and they say, hey, now I have all the information, what do I need to do? So it say, okay, not attributes, you have done that, you have got the information, you now have to use get mentor profile. How does it know? Because in the prompt we have said so. In the prompt we say that as soon as you find one mentor that is available, that returns true, call the get mentor profiles. So now the pool has access to more tools, more than one, and it says that once you get information, do this. So it is doing that. So it makes a call to, it has to make a call to get mentor profile to return the final answer. So here if you see, here the ReAct flow is happening. It goes to availability check, tool, again go back to availability check, tool, again go back to availability check, and then out. So here the ReAct flow is happening. So if you would have understood ReAct flow, here it is happening. Okay. So it will go and make a call to get mentor tool, and with this M002 argument, come here, it will return nothing but the information about that particular mentor, and then after tools will be done, which will do nothing, which will say, hey, return the active node. What was the active node? Availability check. The active node was a availability check, which will again make a call to LLM with all this information, with the information like this is the doctor who is available with this particular expertise, say, and it will say, hey, do I need to do anything else? The LLM says, no, you have all the answers, you have everything to answer to the user. So say, hey, the available mentor for Python is Dr. Johnson, whose expertise includes Python and data science, and see that it does not has any entry for the tools call. So for this specialist node, it will come here, it say, hey, now I have the response with all this information, and the response is like this, but and it does not have a tool call. It does not have a tool call. So it will come here, it will return this response and increase the current node index. So the current node index was 1. Now the current node index will be what? 2. Okay. Now after specialist, go back to this. Now this specialist has run, it will go back to this conditional edge and we'll call this after specialist. After specialist will say, hey, it has a tool call. No. So it will go to dispatcher. So it will go to dispatcher. Now the current node index is 3, 0, 1, 2, 3, everything has run. There is nothing to run. So let's go back and see the code of dispatcher. Here dispatcher say, hey, the current index is 3, which is greater than the plan, which was 2, which is 3, size of the plan. So we have to return the format response. So it will return format response, this after dispatch function, which will run which node? This will run format response node. Now let's go to the format response node, which is nothing, very simple. The prompt here is summarize the mentoring program recommendations in a concise manner, including the employee name, availability mentor, and their shared profile. Okay, that's it. That's all you have to do. And once you do that, return the response. Simple, easiest node in the whole graph, right? So it returns this. Dispatcher will go here, returns this. Okay, and then see here, you'll love it. Here we are ending. Once it reaches this node, add an edge to end the flow. So it ends the flow and returns this output. So the same output, but the architecture is different. The architecture is that it will keep go. We have different pools, right, with their own expertise. So in future, if we want to add more functionality, we'll have to just add to a specific tool. We will not have to touch the entire agentic system. So this is how the system is scalable, right? And this is how the system is, like, if one pool fails, there is no single point of failure, right? We have eliminated that scope of single point of failure. So this is how the system, this node pool architecture, is scalable in comparison to ReAct framework architecture for implementing agentic AI system. Thank you very much. I'll close the video now.